Welcome back to the Deep Dive. Our mission today is, well, it's a big one, exploring what it actually takes to build trustworthy AI.
Yeah, and maybe even more importantly, how we defend it in this emerging agentic era.
Exactly. We want to cut through some of the noise and go straight to the people, the engineers who are actually designing the guardrails.
Right. We're drawing on some fantastic insights today, mainly from a recent Stanford discussion. It featured two, really major figures in AI security.
Mhm.
We've got Neil Dwani, who was formerly at Google, Twitter, and now leads Stanford's advanced cybersecurity program.
Impressive background.
And Venet Raalo, who guided the AI safeguards team at Anthropic, after a long stint, like 15 years, and trust and safety at Google, YouTube, places like that.
And what I find fascinating is where they first crossed paths. It wasn't in some, shiny AI lab of the future.
No, not at all. They actually met way back at Google, fighting ad fraud.
Right. Specifically dealing with this thing called Clickbot A. Sounds pretty nasty.
Oh, it was. And that fight, that early work against Clickbot A, it sort of defined their whole approach. Their focus was on building systems, detection and response systems in areas where there wasn't really any ground truth.
Ah, okay. So no easy yes or no answer.
Exactly. No simple binary for whether a click was bad or not. They had to use these probabilistic models, predictive models. They even co-authored a chapter on it, actually.
And that whole idea of fighting something where you don't have a single clear right answer, that feels so relevant now, doesn't it?
Absolutely. We're asking LLMs questions where the answer is often complex, maybe ambiguous.
So that ability to manage the gray space, which they learned fighting click fraud decades ago, it connects directly to the uncertainty we see in AI outputs today.
It really does. It links that historical work, detecting deception, with the modern challenge of defining truthfulness in AI.
Mhm.
In both cases, you're building systems that have to operate when you just don't have definitive certainty.
Okay, let's unpack this then. Before we can even talk about securing AI, we probably need to get a handle on what trustworthy AI even means.
And that's way harder than it sounds. It's like exponentially harder than defining trustworthy traditional software.
How so?
Well, think about it. If you want to define a trustworthy mug, you just ask, does it leak?
Right.
Simple.
Yeah, it's straightforward.
But AI, it has such a broad range of functions, and it's often non-deterministic. So we need a much more multidimensional definition.
So Venet Raalo offered a kind of foundational baseline for this,
Yeah.
right? Starting with the functional side.
Yeah, she laid out 5 essential conditions. First up is technical robustness.
Okay, meaning?
Just reliability, basically. Does it deliver the outcomes it's supposed to?
Yeah.
Then that ties directly into functional safety.
Just
The absolute requirement that the system must not mislead users or, cause harm, whether that's physical or informational, critical stuff.
got it. And then there's the human element.
Right. Human and social appropriateness. This is huge. It means you need to proactively avoid unwanted bias.
So making sure it works fairly across different groups, countries, languages, that sort of thing.
Exactly. Then number 4 is explainability and interpretability. We have to get past this idea of LLMs just being stochastic parrots or, black boxes.
Users need to understand the why, not just the what.
Precisely. And finally, number 5, respectful of the user. So robust privacy, data protection, all built in from the start.
Okay, so that gives us a really solid operational and ethical baseline. But Neil Dwani brought in a wider perspective, referencing the Trust LLM paper.
Yeah, that was a big collaborative effort. Universities, IBM, ML Commons, a lot of players. And it adds some crucial layers, especially for generative models. It brings the total to 8 core properties.
Because generating content adds new risks.
Totally. So the first extra pillar is one we hear about constantly, truthfulness.
Right, dealing with the hallucinations, when the model just confidently makes stuff up.
Exactly. And the key technical lever they point to here is something called retrieval augmented generation, RE.
Okay, RE. How does that help enforce truthfulness?
It's actually a clever separation of concerns. The retrieval part goes and grabs information only from specific, approved, factual sources, like a trusted database or document set.
Yeah.
Then the generation part, the LLM, its job is just to synthesize that retrieved information into a normal-sounding answer. It stops the model from just winging it based on its massive, sometimes messy, training data.
So it constrains the possible answers. Makes sense. What's the next pillar?
This one's ambitious. Machine ethics.
Whoa, okay. How do you even begin to program ethics, especially given all the different legal systems and social norms around the world? Isn't that almost fundamentally unsolvable?
It's probably the deepest challenge, yeah. The goal is to ensure the AI's responses align with, let's say, generally accepted ethical human
A
values.
big ask.
A huge ask. The sources are clear. Achieving this kind of alignment is tough even for human governments, let alone code. The technical challenge is programming that alignment so the model resists being tricked or jailbroken into doing harmful things.
And the final one sounds sticky. Accountability.
Uh-huh. This is the really tricky one. If an AI, which we've established is non-deterministic, gives a wrong answer that harms someone financially, medically, whatever, how do you hold it accountable?
Right. You can't exactly fire the algorithm like you would a human employee.
Precisely. You've got this non-deterministic system, meaning you can't always predict the exact output, which kind of breaks traditional liability frameworks, like for faulty products. So establishing clear lines of liability is absolutely central if we're ever going to truly trust these systems in high-stakes situations.
Okay, so let's recap the full 8. Truthfulness, safety, fairness, robustness, privacy, machine ethics, transparency, interpretability, and accountability.
Yeah.
That's a lot.
It is. And it immediately brings two corporate functions that were often totally separate crashing together: safety and security.
Yeah, historically they lived in different worlds, right?
Completely.
Yeah.
Safety teams were focused on, catastrophic harms, preventing models from spitting out bioweapon instructions, child safety risks, major societal harms like systemic bias, big picture stuff.
While security teams, the CISO's world, were worried about data breaches,
Yeah.
supply chain attacks, protecting the company's internal secrets, the crown jewels.
But now, with agentic AI, they're suddenly operating on the exact same territory. The classic example they use is the autonomous coding agent.
Okay, explain that intersection.
So imagine this agent gets a task, breaks it down, and decides it needs an external tool, maybe a package from NPM or pip.
Standard developer stuff.
Right. But now the safety team has to evaluate the transaction itself. Is calling that specific package inherently dangerous?
Okay.
Is the package malicious? But the security team has to look at the potential outcome. If that package is malicious, did our internal security setup prevent it from stealing sensitive company data?
Ah, I see. So both teams are responsible for different aspects of the same single action by the AI.
Exactly. They absolutely have to work together now from the design stage, which points to the one habit they both need.
Oh, jizz.
Be paranoid and be prepared. Think about abuse cases, not just use cases, right from the start.
That collaboration sounds essential, but it runs right up against the biggest pressure in AI right now. Speed. Everyone's racing to get their models out there.
Yeah, the speed to market pressure is intense, and speed is often the enemy of thorough safety and security checks.
We've seen this movie before, haven't we?
Absolutely. Remember Facebook's old motto, move fast and break things?
Oh, yeah. Famous last words.
Well, it led to repeated, massive data breaches and other problems. They eventually had to change it to move fast with stable infrastructure, but only after the breaking things part forced them to get serious about risk.
So the lesson is, rushing things can actually slow you down in the long run.
Totally. If you deploy a complex AI too fast without the right guardrails, you face huge cleanup costs, potential regulatory fines, massive reputation damage. It all ends up being slower than being careful upfront.
Reckless speed is actually slow speed.
That's the core insight.
Yeah.
Real speed needs strong, balanced guardrails.
Okay, here's where it gets really interesting for me. You think about the German Autobahn. Why can people drive incredibly fast there?
Good analogy.
It's not because there are no rules, right? It's the opposite. It's because the whole system, the road design, the rules themselves, driver training and discipline, it's all incredibly robust.
So speed requires appropriate guardrails, not just getting rid of them.
Exactly. You need that stable infrastructure to move fast safely.
And that need for robustness, for solid guardrails, it's complicated even more by the nature of LLMs themselves. You can't test them like traditional software.
Because they're not deterministic.
Right. You put the same input twice, you might not get the same output. So testing has to be sampling-based. It's probabilistic. You're testing against likelihoods and patterns, not checking against fixed, predictable logic.
That inherent uncertainty, that probabilistic nature, it leads us straight into the biggest new technical threat landscape, agentic AI. and specifically its vulnerable underbelly, the Model Context Protocol, or MCP.
Yeah, agentic AI is where the model takes a complex goal and figures out the steps itself, breaking it down, calling external tools, checking results, coordinating everything autonomously.
Sound powerful.
It is powerful, but it's also seen as maybe the biggest new risk area, even if it's a bit overhyped sometimes.
Yo.
The real problem is the communication layer they use, the MCP. It just wasn't built with security in mind.
Okay, tell us more about this MCP. What does it do, and why is it so insecure?
So the MCP is basically the handshake protocol. It's the language these different parts of the agent system use to talk to each other, assign subtasks, get results back, decide what to do next. The fundamental issue is that it was designed mostly as an internal mechanism. Think of it like the really early days of the web, with HTTP before we had HTTPS.
Ah, okay. No built-in security.
Exactly. No built-in authentication to verify who you're talking to, no inherent verification of the data coming across, often no mandatory encryption. It assumes trust.
And if that core communication protocol is insecure by default, that creates openings.
Big openings for things like prompt injections, for unauthorized data exfiltration, for running untrusted code. If an agent just assumes any input arriving via the MCP is a legitimate instruction or trustworthy data, you're completely exposed.
And this gets worse when we look at coding agents specifically. I've heard the term vibe coding thrown around.
Yeah, letting the AI write your game. The problem is, studies are showing that the code these agents produce is often less secure than code written by human developers who follow standard security review processes.
Why is that?
Well, many of these models were trained on vast amounts of code scraped from the internet, places like GitHub, and a lot of that code, it's not secure.
So they learned insecure patterns.
They learned insecure patterns and confidently reproduced them. Plus, there's the human factor. A recent survey found 63% of security leaders said their biggest worry was employees feeding sensitive data to AI agents that they really shouldn't be.
Okay, so let's drill down on the number one technical threat that this fragile MCP enables. Prompt injection. Can you define that clearly for us?
Yeah, prompt injection is really insidious. Basically, an attacker finds a way to slip malicious data into the prompt stream, maybe before the user's request, after it, or even hidden inside data the agent fetches.
Okay.
And the backend AI system mistakenly interprets that injected data not as harmless input to be processed, but as a control instruction, a command that overrides what the user actually asked it to do.
That sounds eerily familiar, like SQL injection from decades ago.
It's the exact same fundamental failure. The system can't reliably distinguish between data it's supposed to handle and commands it's supposed to execute. Data versus control.
So if the problem is fundamentally the same, does that mean the defenses also draw on older, established security principles?
Absolutely. It means we need to diligently reapply some of the most you could say boring but proven security practices we already know work.
Like what? What's the core defense?
The thematic defense is always maintaining that clear separation between data and control instructions.
And how do you enforce that technically?
One key technique is using cryptography, not necessarily for encrypting everything, but for signing the instructions.
Signing.
Yeah. You cryptographically sign the legitimate control prompts, the ones from the user, or the subprompts generated by the agent itself, but you explicitly do not sign data that's pulled in from the outside world, like from a web page or a user form.
Ah, so the system can instantly tell signed instructions apart from unsigned data.
Exactly. It creates a cryptographically guaranteed separation. This input is verified control. This other input is untrusted data. Handle accordingly. Anthropic even did things like putting clear headers on responses shared between users, warning them not to treat it as a command if it came from someone else.
Smart. What other boring principles apply?
The principle of least privilege, or minimal access.
Always a classic.
And absolutely critical here, you need to implement strict access escalation controls. The rule should be any downstream subprompt or subagent must have lower access rights than the agent or prompt that called it.
So if one part gets compromised by an injection?
Its blast radius is limited. It can't suddenly access everything the top-level agent could. You contain the potential damage immediately.
Makes perfect sense. And the most basic security rule of all.
Don't trust user input, or any external input, really. Vet it, sanitize it, validate it before you let the AI process it or make decisions based on it.
So these fundamental, maybe unglamorous security habits are still the best defense against these novel AI attacks.
They give you maybe 80–90% of the protection, honestly. Things like careful prompt engineering also help, training the model to follow a strict hierarchy. Its post-training safety rules override the system prompt, which overrides the user request, which hopefully overrides any injected text.
Okay. Let's quickly touch on the other big attack types. What about jailbreaks? Tricking the model into ignoring its safety rules.
Yeah, those are tough. The main defenses there involve really strong system prompts, clear instructions on what the AI should never do, and also using techniques like constitutional AI.
Constitutional AI.
It's like giving the model a core, non-negotiable rule book, often based on principles from things like human rights declarations. This constitution helps make it fundamentally resistant to being manipulated into violating its core safety guidelines.
And then there's the really big picture worry. Catastrophic harms. We're not just talking data breaches here.
No, this is the macro level concern. The risk of, say, models significantly lowering the barrier to designing dangerous things like novel viruses, the kind of asymmetric destruction potential.
That's sobering.
It is. But there are also broader societal harms to consider. Like, if this incredibly powerful and expensive AI tech mainly benefits the richest countries or corporations, it could create massive new inequalities and societal divides.
So pulling it all together, the message seems to be, to handle these new agentic risks, these prompt injections, we actually need to look back at the lessons learned from fighting things like Clickbot A, like SQL injection.
That's exactly it. So what does this all mean? It means we have to reapply that existing hard-won security knowledge. It's not about throwing everything out and starting over.
It's about applying proven techniques in a new context.
Right. Use cryptography for signing control. Enforce minimal access, never trust input. And crucially, bring the security experts into the conversation early.
The security design review.
Yes. Have those proactive discussions during the design phase, not after something's already built. That's how you catch 80–90% of the potential problems quickly and efficiently, balancing that need for speed with actual risk management.
This has been an incredibly useful deep dive. We've gone from defining trust all the way through to the nitty-gritty of prompt injection defenses. It's easy to focus on the risks, maybe feel a bit overwhelmed.
Understandable. But the sources also offered some real reasons for hope, which I think is important.
What stood out on the positive side?
Well, first, the field is surprisingly open right now. Companies, even competitors, are actually publishing a lot of their safety research and techniques. That's not always common in tech.
It's encouraging.
And governments seem to be acting faster than usual, too. You see movement in California, the EU, the UK, trying to get governance frameworks in place much earlier in the tech cycle than, say, with social media. And maybe most importantly, there's already a large experienced community of security and safety experts out there whose skills are directly applicable. We don't have to invent everything from scratch.
And that community needs to grow. It includes you, the listener. If you're interested in AI, especially the security side, the field needs more critical thinkers.
Absolutely. We can only really harness all the amazing potential benefits of AI if we have enough skeptical, careful people involved in building those essential guardrails. The work needs that paranoia, that preparedness we talked about.
Which brings us to our final thought for you to maybe chew on after this.
Yeah.
We've talked a lot about how LLMs are non-deterministic, how there's inherent uncertainty.
Right. The outputs aren't always predictable.
So given that, how long do you think it will take until we have really reliable, established liability frameworks for when AI systems do cause real-world harm? I'm thinking things like mandatory insurance, clear regulatory lines for accountability.
That's the million-dollar question, isn't it?
How do we bridge that gap between this probabilistic digital technology and the need for concrete, real-world accountability and trust? Something tied to that eighth pillar, accountability.
A question that will likely define a huge part of AI governance for the next decade.
Definitely something to think about. Thank you for joining us for this deep dive.
Thanks for listening.
See you next time.